Kansas City. Friday evening, July 17, 1981. 1,600 people are packed into a hotel lobby for a tea dance. The band is playing Duke Ellington. And 40 feet above the dance floor, two bridges of concrete and steel hang from the ceiling on slender rods, with people standing on them, swaying to the music. At 7:05, both bridges let go. 114 people never went home. It was the deadliest structural collapse in American history until September 11th. And when investigators finally traced it back, they did not find corrosion, or an earthquake, or a bomb. They found a pencil change on one drawing, one line that nobody ever calculated. This is how a single drawing killed 114 people. 1 year earlier, the Hyatt Regency is the pride of Kansas City. 40 stories, brand new, with a showpiece nobody else has, a glass atrium 5 stories tall, so vast that 3 walkways float across it in midair, hung from the ceiling like bridges in the sky. You could stand on them and watch the whole lobby glitter below. On Friday nights, the hotel throws tea dances. Big band, cocktails, hundreds of couples. The walkways become balconies for the crowd. It is exactly the scene the architects dreamed of, people standing in the air. Here is how those bridges stayed up. The 4th floor walkway hung directly above the 2nd floor one, and both were meant to share the same set of steel rods, running from the ceiling through the 4th floor walkway all the way down to the 2nd. Each walkway gripping the same rod, like 2 climbers on one rope. That was the original drawing. What nobody knew, even that design was weak. Investigators later calculated it could carry only about 60% of what the building code demanded. The margin of safety that every code assumes, the buffer for crowds and bad luck, most of it was already gone, on paper before a single beam was hung. Understand what was actually hanging up there. Each walkway was 121 feet of steel and concrete, longer than a basketball court, and each one weighed close to 64,000 pounds. There were 3 of them. The 2nd floor and 4th floor walkways hung in a vertical stack, one directly above the other, sharing those rods. The 3rd floor walkway was different. It hung off to the side, on its own supports, alone. Remember that detail because it is about to matter. And here is the part of this story almost nobody knows. This building had already collapsed once. In October 1979, while the hotel was still under construction, 2,700 square feet of that atrium roof came crashing down. It was 6 in the morning on a Sunday. The site was empty and nobody was hurt. The owner demanded answers. The engineering firm promised a thorough check of the atrium structure, but that check never reached the walkway connections. Building had sent a warning in steel and broken glass, and the one detail that mattered was never looked at. So on a crowded Friday night, these were not just bridges, they were a stage. About 40 people were counted standing on the 2nd floor walkway that evening, and up to 20 more on the 4th, all of them leaning on the rails with drinks in hand, feeling completely safe. 32 tons of concrete over their heads, 32 tons under their feet, and all of it hanging from a detail that no one had ever checked. Then came the phone call. The steel fabricator looked at those long, continuous rods and saw a manufacturing headache. Threading a rod for 40 feet is expensive and awkward, so they proposed a simpler detail. Cut the rod in 2, hang the 4th floor from the ceiling, and then hang the 2nd floor from the 4th. Same look, easier to build. The engineering firm approved the change over the phone, without running the calculation. Look at what that change actually did. The 4th floor connections now carried both walkways instead of one. The load on those box beams doubled. A detail that was already too weak was now holding twice the weight, above dance floor every Friday night for a year. July 17, 1981. The tea dance is in full swing and dozens of people are standing on the walkways to watch the band. Inside the 4th floor box beams, the nuts and washers on those doubled up rods are slowly pulling through the steel. At 7:05, one connection lets go. The load races to the others, and they follow in seconds. The fourth-floor walkway falls onto the second, and both crash together onto the crowded dance floor. 65 tons of concrete, steel, and glass. 114 people are killed. 216 more are injured. Firefighters work through the night with jackhammers and cranes, and doctors perform surgery on the lobby floor. By morning, Kansas City is a different city. What followed became the longest night in Kansas City's history. The falling walkways had torn open the hotel's sprinkler pipes, and because those pipes fed from tanks instead of a street connection, there was no valve to close. Water poured into the lobby, and people pinned under 60 tons of concrete were now at risk of drowning in a hotel ballroom. The fire chief made a call that has entered rescue legend. He sent a bulldozer through the hotel's front doors, smashing them open so the water could escape. Construction companies from across the city arrived with cranes, concrete saws, and jackhammers, and crane booms were pushed straight through the atrium glass to lift the slabs. The rescue ran for 14 hours. 29 people were pulled alive from the rubble. The last of them, a young man named Mark Williams, had spent more than 9 hours trapped under the lower walkway, nearly drowning before the water was stopped. By the time the sun came up, this was no longer an accident scene. It was the birthplace of modern urban search and rescue. 4 days later, investigators from the National Bureau of Standards walked into the wreckage. They photographed every fracture, tested the steel, pulled the drawings, and rebuilt the box beam connections in a laboratory to watch how they failed. Then came the math. The connection as built could resist about 31% of what the code required. Not 90, not 70, 31. And the original design, the one on the contract drawings, 60%. Every number told the same story. This was never going to hold. The change did not break a safe design. It broke a design that was already broken, and nobody had ever checked either one. The engineers of record were found guilty of gross negligence. They lost their licenses. No one went to prison. The hotel reopened, but the walkways were never rebuilt the same way. The replacement stands on solid columns, planted on the ground, holding nothing in the air, and the collapse became something bigger than a lawsuit. It became the case. The one taught to every engineering student in America in every ethics class for 40 years. The lesson is brutally simple. A 5-minute calculation would have caught it at any point, by anyone. The drawings still exist. 2 details side by side, the original and the change. The difference between them is a few inches of ink. 1 rod became 2. That is the entire distance between a Friday night dance and 114 funerals. Check the math every time.